So here is our second to last problem. And so let's see what I have here. I've got a some form of a wrench, and here's what we're going to be told about this thing is that there's a clamping force here. So the wood is pushing back, or this is pushing down on the wood. It's in stable equilibrium. So there's a clamping force here of 600 newtons. So this would be pushing 600 this way up, 600 down, or this thing is 600 down, 600 up on the wood. Then the question is what hand force does it take to accomplish that 600 Newton clamping force? Okay. So in doing these problems, the most important thing is just getting a good set of free body diagrams and thinking your way through it. Because usually once you have a good set of free body diagrams, the answer kind of speaks to you, usually relatively quickly. Now when I look at doing the free body diagram, all that really matters are the points of connection. So we have A, B, C, D here, the top and bottom spots with the wood, and then where the hands are. All right? And so you want to get those orientations accurate. You have to get them very accurate. But then how you draw the rest of the device can be sort of cartoonish. It's just enough to kind of show how things connect so you can get your head around it, but having it look perfectly like the picture here is not at all needed. All right, so here's what we're looking at. Let's go and develop the free body diagrams for this thing. Okay, and so here's when I said cartoonish, I was not kidding. This is what I have. This looks like two little lamb chops here. I'm not sure what you call those, but anyway, the key is showing that we had that top line, and then here's where D is down here, connecting to the bottom piece. And I've taken the time just to show, okay, the force that came up through from the wood. This shows where D is, where A is, all right? And then I can see how far down the connection is. So the important spots are locating all the various joints or where forces are happening. Likewise in the bottom, you can see I've located where the spacing between D and C. Over here, I've shown the spacing from C back to B. And then I'm lining these, the P's are lined up inherently. But you can just see I've taken the time to basically accurately show, I've blown it up into sort of a schematic so you can see how it would fit together, and I've gotten all the proper dimensions, and then I just drew enough of this thing so I could kind of get the feel of it, seeing what's going on. Okay? So now the next thing is to kind of think your way through this and start assigning forces. So in doing that, so here's what I would do. I'm going to just kind of look at a strategy. Notice here, this force is given. It's 600 newtons. Okay? If I could figure out, and the question is, what is A? If I could, or what is P, the clamping force at the hand. If I could express what's going on at A in terms of P, notice what I have here. I know this. If this was in terms of P, I could then take the moments at D and I could solve for my unknown, and bam, I'd be done. So my goal here then is to express the forces at A in terms of P. I really just want to go along this line to the extent that I can. All right, so I got a bit of a plan. We'll see how that works out. So now I'm going to start trying to think out, okay, how do these forces work? All right, so if I picture just holding B still, if I were to take this thing and with the clamp start using my hand to move that down, this is going to go this way. Well, that immediately tells me that this thing here is going to oppose that, so it's going to be pulling this way, so I'll put it in AX. And then if this is pulling that, this is pulling the other thing, so I'm guessing this goes this way, and so I'm guessing then this thing pulls on that thing. So boom, I've got my first one in there. Now, notice how, let's just go back to the picture for just a second. And so as I clamp down on this B is going to rotate up just a bit. All right? So in doing that, that's going to, as this goes up, that means this thing is going, I think this is going to give an upwards force on this piece. All right? So as this all goes up, because this is going to be forcing that up, this thing will be giving a little lift up here. Okay? If I'm wrong, I don't care. I'll get a negative sign. So I think this is going to go up a little bit, so I'll put AY up here, but that means AY on the other side. If this one pushes that up, this one's pushing down on that. All right? So one thing determines the other. Let's just make this easier to see. All right? Maybe not easier at all, but oh well. AY. There we go. So I have AY up, AY down. AX to the left, AX to the right. Now if this is down and this is down, well that says that BY must be going up. Has no choice. These two are going up and down. This is to the left. That means there must be a BX going to the right. But if this is up here, BY is down here, BX is over there. Okay, this is going up. So let's just kind of move on this way. If this is going up and this is going up, that says there has to be a force dy pulling this down, which means there's one pulling up there. If this is going to the right, then we have a dx going to the left, which makes the dx here go to the right. But this is going up and down to the right. That puts a cx here to the left, which puts a cx there to the right. Okay. Now, the rest of the way, what's going? Let's see. Hard to say. All we have left is what is the CY's doing here. And if I'm looking at this thing, as I pull this thing up there, this thing's going to come back a little bit. And so I think this piece is going to push up on that C. Free choice. If I'm wrong, I'll get a negative sign. I don't care. And then CY there. All right, so I've got forces put in for everything. So what I want to now do is just start, I'm just going to kind of start walking through this system. I'm going to start from here and try to work my way across and get information. Okay, so let's see. So starting on this one, I'm going to sum the moments at B because I'd like to go straight across. I'm going to have difficulties, but I don't care about B all that much. So I'm going to sum the moments at B and see where that takes me. All right. So you will notice that A and B are aligned. So AY has no moment. So I'm going to take the moments at B. AY does nothing. I'll have AX as a contribution. P is perpendicular, is vertical, so all we care about is the horizontal distance. So if I sum the moments at B, I have P relative to B is going clockwise. So we have minus P times 0.14 meters. AX is going counterclockwise. AX times 0.05. All right. We set that equal to 0. Solve. And we get AX equals 2.8 P. So I got that in terms of P. That's good. AX equals BX. Because this goes to the left, that's got to go to the right. So I'm halfway there of getting this defined the way I'd like to. All right. Now notice I have a P. Because I know BX here, I know BX here. So I'm going to take the moments here at C, which has this P factor sitting down here. And since I know Bx, I'm going to get By out of it. All right? So that's the next thing I'm going to do. So I'm going to sum the moments at C, which has P again. So C does nothing. And let's see, so I have P, and if we look at where P is, it lines up with the top one, and there's 140 millimeters plus an extra 20. Okay? And so relative to this, it's going counterclockwise, so I have P times 0.16 meters. Boom, done. Okay, Bx, I know Bx. Bx, it's 50 millimeters up, and so that looks highly clockwise too. Bx is 2.5 P, so I'll just put that in right now, and that's 0.05 for the moment arm. And now I have By coming down. Have no idea what By is, but as By comes down, so we'll just follow that force down here. So that's clockwise. So we have now minus By times 0.02. All right? We set that equal to 0. We solve for By. We come up with 15P. All right? So I got By in terms of P. All right? So I go up here, and now I'm going to sum the forces in the Y. I have, on the top, a minus P. Let's see, I have minus AY. And then I have plus BY, which is 15P. So, bring the AY to this side. I get AY equals 14P. Okay, this is great. AY is 14P. AX is 2.8P. So now I have AX over there. I'm going to sum the moments at D, and we're going to be out of this puppy in just a moment. So we go here, we sum the moments at D. Summing the moments at D, set that equal to 0. So I had 600 newtons coming up, and this is relative to D, the horizontal distance, 0.14 meters away, and that looks extremely clockwise. Minus 600 times 0.14. Done. AY is going up, and so relative to D, that's counterclockwise, so plus AY times 0.8085. Too many decimals. All right. And then I have AX here going like so. So that looks clockwise. Minus AX, and that's 0.05. And so that I just focused on getting the equation. Now I'll stick the P stuff in. So minus 600 times 0.14. AY was 14P. 0.085 minus AX is 2.4P. 2.8P, sorry. And I have one equation, one unknown. Solve for P. Get 80 newtons. So we put 80 newtons on both sides, our clamp. And so we wind up with 7.5 times more force than the other side, if I did the math right in my head, to get 600 newtons. And we will stop this video right here. We have one more to do, and we'll be done with this chapter. Bye for now.